Let's talk a little bit about the different kind of ways that we can record audio and the different kind of formats that you'll find on different computers. This sometimes can be confusing as to people as to what kind of format, how much memory that's taking up, and the quality of that. So this is referred to as the audio file formats. There are basically three major groups of audio file we can talk about. The main one that you use in recording studios, professional recording studios, is what's called an uncompressed file format, which means that when you record, your sampling rate of say, audio is going to be at 48,000 or 44.1 thousand samples per second, or in professional studios, you usually will go even higher to 96 or even above. So when you're recording that, you're getting a lot of data that's representing the sound file into the computer. And for a professional level, you don't really want to have that compressed. You want to keep the file and as much information about the sound as you possibly can, so that as you work with it and edit it and mix it and so forth, you're not diminishing any of the potential sound. So the uncompressed audio formats that you will find are referred to as the WAV or the AFF or the AU, or sometimes the raw headerless PCM files. Those are the files that are going to be the largest size because of the amount of information in them. There's a second category referred to as lossless compression. And this is a type of compression where we, as it says here, stores data in less space by eliminating unnecessary data, so that no data is permanently removed. The audio data is just packed to save more space. So what you get in this kind of format is, by reducing just the way it's stored, is you get about a 50% reduction of sound in that. This is in some ways the most preferable of the compression formats, because you're not actually losing any of the original data. You're just reorganizing into a kind of a tighter space of that, but you don't get that much saving of memory of that. What you find more often is what's called the lossy compression. And lossy compression, these are a compression algorithm which takes the data and tries to figure out which of the information that has been sampled and stored is not necessarily information that's going to be heard as much. And what it does, it figures that out and takes out the data that is not really going to be affecting the sound to any great degree. But there is a reduction of the amount of data that's representing the sound in this format. So, but it's much better than, say, lowering your sampling rate. If you take your sampling rate from 44 down to 22 or even lower, you will hear a very audible reduction in the quality of the sound. You're not representing the higher frequencies. You're getting a very dull kind of sound on that. So by just strictly reducing the sampling rate doesn't accomplish that. What this does, it reduces the amount of data per second, but it does it in a more intelligent way. And these are the kind of systems you probably will find on your mobile devices, and most of the MP3s and so forth you will find in this lossy compression style. And what you end up getting is often an 80 to 90% reduction in the size of the file. So when you have a little iPod or some small device that's got thousands of songs on it, those are in a compressed, lossy compression format. The only way you could do that on memory is to put them into that reduction. So going back, looking at the first category, the uncompressed audio files, usually these are going to be in a 1624-bit, remember those are computer numbers, or you can find them in the 32-bit floating point numbers. So these are all referred to as pulse code modulation, or PCM is the sort of name that refers to these. And the most prominent one is maybe the .wav file, which you probably have all seen. This is the standard format that you find on the Windows operating system, but it can also be read in the Macintosh as well, because all these are essentially the same amount of data. When you record something in at 44 or 48,000 samples, whether it's a WAV or AFF or whatever, it's still the same information is there. It's just some other coding that makes it into a WAV file or AFF. So you see here, the WAV format is based on the resource interchange file format, RIFF, whereas the AFF, it's the same information, but it's based on the interchange file format, and it's mainly for the Macintosh. But most computers can convert those back and forth, because there's very little information that has to be converted today. What you find in Europe primarily is the BWF format, which is the broadcast wave format, similar to WAV, but it has a different kind of protocol for the European broadcasting standards. So those are the three kinds of uncompressed formats that you will run into. If we look at the lossless compression, One of the more standard ones is the FLAC. This is a codecs, actually. It's a sort of a compressor and a decompressor codecs that allows you to, here again, it's an algorithm that reduces the size to about 50 or 60%. Remember, this lossless compression is not losing data, but it's changing the way the data is organized or compressed and decompressed into that as a kind of a codecs. WavePak is another one, usually abbreviated with a WV. Here again, you're getting anywhere from a 30 to 70% savings of space on that one. For the Apple computers, they have something called Apple Lossless, which the extension sometimes is M4A. You'll see that if you use Apple computers or iPods or any kind of Apple device. Other lossless compression formats are the MPEG-4 versions. This was a continuation of the MPEG-1 and 2 standards. You will see these are used for all sorts of video rendering, for 3D objects and so forth. So there are a lot of applications for the MPEG-4, but here again, it's another type of lossless compression format. And then going back over to the Windows machines, you find the Windows Media Audio lossless format. This is proprietary to the Windows machines. Usually has a hard time working on the Macintosh machines. And there are different kind of codecs for the WMA as well. If we go then to the lossy compression, here again, this is the one that you most commonly find. The MP3 was one of the first successful versions that was developed in this, or referred to as the MP2 layer, audio layer 3 was the official name of it. And here again, it's a audio specific format designed by the Motion Picture Experts Group, MPEG, as part of its MPEG-1 standard, and later extended into the MPEG-2 standard. So the MP3 files use the 128 kilobit setting as the sort of standard for that, and it results in about a 1:11 ratio of the original size of your uncompressed format, which is a great reduction. So when you originally had your MP3 players, you could put thousands of songs on that, and without really good sound speaker systems, most people couldn't tell the difference between the uncompressed format. Once you get into a reasonably good set of headphones or speaker systems, you can usually tell the difference. And in my classes, I will often play sound files both in the lossy compression format and in the uncompressed. And in good studio monitors like we have in here, you can clearly hear the difference in those relationships. And then there are a few other ones. The Vorbis, which often uses the OGG container format, is becoming more popular. The ATTRAC, also the Adaptive Transform Acoustic Codexing, is another one that you found originally on the mini disc by Sony. That one is not as much as in use today. MusePak is another MPC, is another lossy codec format. ACC, I mentioned the Advanced Audio Engineering, is the one that has replaced MP3, developed by Apple Computer primarily. So if you go to YouTube or iPhone or any of these other game devices, pretty much they're compressing now with the ACC format. And I mentioned the Windows Media Audio. There was a lossless version of that, but they also have the lossy WMA, which is very standard now, and you can find it in cross-platforms pretty much everywhere. So those are the main different kind of audio formats you will find. So just remember that most of your computer sequencer programs that we'll be working with will be recording into a compressed format. Once they're, an uncompressed format. Once they're either in a WAV or AFF file, we can then usually export them out of our computer into some kind of compressed format that can be played on your mobile devices. So that's basically audio file formats.
The preceding program is copyrighted by Emory University.